Hello, good morning. Let's start with another problem in continuation with DSU series. So this is the third problem in DSU series. So problem is MooTube. So let's start. In this is past time, farmer John have created a new video sharing service. Okay, which he named MooTube. On MooTube, farmer John's cow can record and share and discover many amazing video. Okay, his cows already have posted in videos. Okay. Numbered 1 to n. Okay. Completely number 1 to n. However, MJ can't quite figure out how to help his cow find out new video they might like. Okay. So cows have posted in videos and we need to suggest some videos to cows. Okay. FJ want to create a list of suggested video for every motive video. So for a video we want to suggest some videos. Okay. This way, cows will be recommended the videos most relevant to the one they have already watched. Okay. Is we need to cover all they have watched? First, no. Let's see. FJ devises a matrix of relevance which determine, as the name suggests, how relevant two videos are to each other. He pick n minus pair of video and manually compute their pairwise relevance. FG devises a matrix of relevance which determine, as the name suggests, how relevant two videos are to each other. He pick n minus pair of videos and manually compute their pairwise relevance. Okay. Then FG visualizes videos as per network, where each video is a node and n minus one pair of video he manually considered are connected. Okay, so he from n videos he added n minus edges between those videos, and each n minus edge is representing some relevance between the videos. Okay, conveniently FJ has picked his n minus 1 pair so that any video can be reached from any other video along the path of connection exactly one way. Okay, so n minus 1 representing it's going to be a tree, and from any one node we can reach to another node. Okay, FG decided that the relevance on a pair of videos should be defined as the minimum of relevance of any connection among the path. Okay, so from one node to another node, there are going to be edges which need to be crossed, and for each edge, there is a relevance value given. So if we are traveling from U to V, then the relevance of node U and V is decided by the minimum of edges along the path. Okay. Farmer John want to pick a value of k so that next to any given Mojo video, all other videos with relevance at least k to that video will be suggested. Okay. So for if a cow is watching a video U, we need to suggest all the V videos having relevance greater than equal to k. A relevance is calculated as if we travel from U to V, then the minimum of edges along the path. Okay. However, since FJ is worried that too many videos will be suggested to his cow, which could distract that from milk production, therefore, he wants to carefully set approximate value of k. Farmer John would like your help answering number of questions about the such value for certain value of k. Okay, so there are some given values of k and v, and for a given node v and k, we need to find all the nodes which you need to be suggested with given v. Okay, let's move to the input format. We are first line we are given n and q, that is depending number of node and number of queries. Next n minus 1 lines, each describing pair of fj manually compares. Each line includes 3 integer uv and ri, indicating video q and pi are connected with relevance ri. Okay, so we are given h and its weight. Next q line describe farm John's query. Each line have 2 integer k and vi, indicating fj question asks how many videos will be suggested to viewers with video vi if ki is ki. Okay, okay. Let's move to the output format. Output q lines. The ith line is output of the fj's ith question. Okay. So let's move to the input and let's see how we want to check. Okay. So we are given n as 4 and q as 3. Next, n minus 1 lines we are given edges with weight. Okay, there are 4 nodes, and now let's connect them. One is connected with 2 with weight 3, 2 is connected with 3 with weight 2, and 2 is connected with 4 with weight 4. 1, 2 with 3, 2, 3 with 2, and 2, 4 with weight as 4. Okay, this is the graph which we are given in the input. Now let's see the queries. Okay, we are given k as 1 and v as 2. So for a node v 2, for a node 2, we need to suggest some videos to it. All the nodes, all the videos having a wavelength greater than equal to 1. Okay, so for 2 we need to suggest video wavelength greater than equal to 1. Greater than equal to 1. Okay, so for 2, let's see whether 1 can be suggested or not. So for 1, we need to check path from 2 to 1 and take out the minimum of edges. Okay, so along the path there is only one node having value 3, that is 2 to 1, that is only value 3, and its minimum is 3. As this is greater than equal to 1, this can be suggested. Okay, so 1 can be suggested. Next, move to check 3, whether 3 can be suggested or not. So along the path from 2 to 3, there is only one value, that is 2. There is 2 to 3. There is only value with value 2 as, and minimum of 2 is 2, and it is greater than equal to 1. So this can be suggested. Let's check for 4. 4. Whether 4 can be suggested or not. So path from 2 to 4, as there is only one edge having value 4, and its minimum is already 4. So as this is greater than equal 1, so this can be suggested. For equal to 1 and uv, all 1, 3 and 4 can be suggested. For this, answer is going to be 3. So for node 2, all these 3 nodes can be suggested, as their wavelength with 2 is greater than equal to 1. Now let's move to second, that is k equal to 4 and v equal to 1. So now we need to suggest video to 1 having wavelength greater than equal to 4. Now let's check whether 2 can be suggested or not. So along the path from 1 to 2, values are, there is only one node and its value is 3, and there is its minimum is all node is already 3. So this is greater than, not greater than equal to 4, so this cannot be suggested. Now next check 4. So path from 1 to 4, there are two edges, that is 1 to 2 and 2 to 4, and having value 3 and 4. So values are 3 and 4, and its minimum is 3. As again this is not greater than equal to 4, then this cannot be suggested. Now let's check 3. So now we need to check path from 1 to 3. So there are two edges, that is 1 to 2 and 2 to 3, having value 3 and 2, having value 3 and 2, and its minimum is going to be 2. As this is not greater than equal to 4, so this cannot be suggested. Okay, so for 1, there is no node having a wavelength greater than equal to 4, so no node can be suggested to 1. So for this, answer is going to be 0. Okay. Next move to the next query having k equal to 3 and v equal to 1. Okay, so again now we need to suggest some video to 1 having wavelength greater than equal to 3. Now let's check for 2. So for 2, 1, 2, two path having only one value, that is 3, and its minimum is again 3, and this is greater than equal to 3, so this can be suggested. Now next check for 4. So 4 path from 1 to 4, there are only two edges, that is 1 to 2 and 2 to 4, that is having value 3 and 4, value 3 and 4, and its minimum going to be 3. This is greater than equal to 3, so this can be suggested. Now let's check for 3, whether 3 can be suggested or not. So there is two edges, that 1 to 2 and 2 to 3, having value 3 and 2, as its minimum is going to be 2, and this is not greater than equal to 3, so this cannot be suggested. So for this, answer is going to be 2. So for 1, the nodes which can be suggested having wavelengths greater than equal to 3 is 2 and 4, as along the path to 3 there is a edge having value lesser than 3, then this is affecting this wavelengths. So this is the question you need to solve. Now I hope this is clear. Let's move to the solution part. Okay. 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 Now for this question we need DSU as we are moving. So DSU having find and that is merge function, and there is, you are already aware, there is a size array which represent the size of a current for a size array for a node, it's a size of connected components. So if we want to find size of component, we first need to find its, for any node we need to find its parent. So this find method we're going to give parent, and using that parent with size array we can find the size of the component. So this will going to give size of component. Okay, so this size is storing size of component, and while we are merging we are updating size of parent. So this part we will be using in current problem. Okay, before using DSU we need to do some pre-processing with edges and queries. So we want to sort these edges and queries. So the what idea we want to do is that if we want to calculate answer for a given k, we want to add all the edges in the tree having weight greater than equal to k. Okay, so first what we want to do is sort the queries on the basis of k. So k and t, and first we want to process all the queries having greater k, that is first we solve for 4 and 1, then 3 and 1, and then 1 and 2. Okay, and second part is that we want to sort edges on the basis of weight. So nodes, that is 2 and 4 and 4, 1 and 2 and 3, then 2 and 3 and 2. Okay, 2 3. Okay, so these are edges and this is the queries. So first queries are sorted on basis of k in decreasing order. Similarly, edges are sorted on basis of weight in decreasing order. And how we are going to use DSU is, for a given k we want to add all the edges having weight greater than equal to this k. And why we are doing this, let's move to the queries and see why we are doing this. So now let's solve for first this k equal to 4 and v equal to 1. So for this k 4 we want to add all the edges having weight greater than equal to this k. As there is only one edge, 2 to 4 having weight 4, this is greater than equal to 4. 2 and 4, that is added having weight 4. So For we want to calculate all the node which can be suggested for node 1. uh, uh, okay, so while just we adding this edge, we are also calling merge function, so these 2 and 4 are going to merge. Okay, and why we are doing this, let's see. If we not do this and also add the next edge having weight lesser than 4, that is 1 and 2 having value 3. Okay, so for this given query we need to find all the node having revealance greater than equal to 4, and for if one we try to find any path along this edge, then definitely this node going to affect it because it have value lesser than 4. So definitely this edge will all the node across this edge will not be considered. So there is no point of for this query, there is no point of considering this edge. I hope this makes you clear. So for current part, we have processed only edges having value greater than equal to 4. For subsequent query, this part will already be satisfied because we already have added edges having value greater than 3. Because for 4, all the edges having value greater than 4 is already added. For second query, we just need to process all the edges between those. Okay. Okay, now for 1, we need to find the size of the component with 1. So for 1, its parent is going to be 1 itself and its size is going to be 1. So for this query, answer is going to be size of component, that size of 1. 1 minus 1. 1 because for 1 itself cannot be such, so 1 need to be subtracted. So for using DSU, we want to find size of V1 and 1 need to be subtracted. Now let's see the next query, that is 3 and 1. 3 and 1 equal to equal to 3 and v equal to 1. Okay, we need to add all the edges having value greater than equal to 3. So 1 and 2 having value greater than equal to 3, weight greater than equal to 3. So this next need to add it having weight as 3. Okay, 1 and 2. Okay, sorry, 1 and 2 having weight as 3. Okay, again we need to find the video which can be suggested to 1. Okay, for this we need to find size of current component, or that is 1. So for 1, we need to find its parent, and then using size array we need to find its size, as size is going to be 3, and this size also considered 1, so 1 need to be subtracted, so it's going to be 2. So for this, answer is 2. How is answer is 2? Then 2 and 4 can be suggested to 1. So and we have already added all the edges having value greater than or equal to 3. So this is the path having value all greater than or equal to 3, and we can reach across all the nodes using all the edges with value greater than or equal to 3. So this 2 and 4 can be suggested. Next move to next query, that is 1 and 2 equal to 1 and b equal to 2. Now we need to add all the edges having value greater than or equal to 1. So next 2 and 3 having value 2, then this edge can be added having value 2. 2 and 3 having value 2. Okay. Okay. Next we need to find what node that can be suggested to 2. So for this we need to find parent of 2, and this using size array with this parent we need to calculate the answer. So size now going to be 4, and this 4 also include 2, so we one need to set it, and it's going to be 3. So for this, answer is 3. and this answer is same as the rest is this 3. And for what is 0, for this is going to be 0, and this last one is 2. So this is the problem how we need to solve. Now next move to the code. So first we are taking input n and q, that is number of node and number of queries. Next we are taking graph. Graph we are taking u, v and w. There is as between u and v with weight as w. We have added two comparator to sort edges and queries. For first comparator is for sorting graph with using weight, it is index 2. Second comparator for sorting queries using k, first index. Next we are storing queries k and v with this I. I is that we are going to sort the queries and we need to print answer in order, so we are storing this I, and we just sort this graph and this query. Now we are storing index j for adding the graph we are having value greater than equal to k. So we have created this answers to store for printing and this DSU for merging the edges. Now move to this part. For current query, we are adding all the edges having weight greater than equal to k. So we merge all the edges having value greater than equal to k. Second part, now for u a u of I2 story. Okay, I2 is this is index. Okay, and for using DSU of size is storing this size array. Okay, now this size array, and for DSU we first find its parent. So this parent is parent of current component, and this parent using size array we are finding the size of current component, and again we need to subtract 1 because this also includes the current node, and storing this into the answer, and this 2 indexes the I we store initially, and next we are printing this. I hope this solution makes you clear. Thank you and bye.